Okay, hopefully everybody can hear me. So good morning, everyone. Thanks for being part of this. And really big thanks to Allie for putting this together. It really was her idea and a lot of effort, and also thanks to IMS for all their support for this. All right, so I'm going to talk about analytic techniques for HINTS. So this has been great. Brad gave you a nice, wonderful introduction about HINTS, gave you a little history. Allie came in and said, hey, here's how you can go to the website and get the data. Now you have the data. Now what? Now I want to show you how you can use the data and do all those kind of cool things with them. And then you can do publishing and go on and do wonderful things and get tenure and make history. All right. And actually, before I even get into this, I'm going to obviously talk specifically about HINTS. But a lot of the issues I'm going to talk about are applicable to any really health survey, population level health survey. So I'm hoping again that'll be really helpful as you think about maybe analyzing other types of data besides HINTS that is kind of that are health surveys. Okay, first thing I want to talk about are statistical weights. Everybody's probably heard that. Okay, weights. Yeah, I want to weight the data and kind of do all those, get those population level estimates, do the modeling so I know what's happening at the population level. So in order to do that, you do need to use weights. Of course, not these types of weights. So what kind of weights am I talking about? So actually, very importantly, I want to distinguish because HINTS will have several types of weights. The first one I want to talk about are what they call the final sample weight. Okay, and by definition, you can kind of see the statistical weight of a sample person is the number of people in the population that the person represents. So literally, if you go to HINTS, you download the data, there's a variable that is the final sample weight. It's just a variable, in your data set, just a column, and it has some value associated with it for each individual. You can see what that is, what that represents. So how are the weights calculated, and what do you use them for? So in the most simple sense, let's go up. In the simplest sense, if you think about sampling, and very importantly, HINTS uses a complex sampling procedure, and I'll talk about that a little more. But let's say your sampling rate is 1 out of 1,000. So you're sampling, you have your sample, and you're taking 1 out of 1,000 people. So each sampled person would represent about 1,000 people. So the basic, if you want to just create a very basic weight, a sample weight, you would take the inverse of that ratio. So the inverse of 1 out of 1,000, of course, is 1,000. So each sampled person would represent 1,000 people, and their weight would be 1,000. And if you think about it, if we have this column of final sample weights, and each person represents a certain number of people in the population, the sum of that column is going to be the number of people in the population that the HINTS sample should represent. Now for HINTS, the population we're sampling from is the adult 18 and older, non-institutionalized US population. So again, if you took the sum of the column, that's what that number would represent for whenever that year of HINTS was done. Okay, how are weights derived? They're actually derived from several things. We talked a little about the selection probability. Because HINTS is a probability-based sample, we know the probability of someone being sampled. Again, that's why we can actually create the weights, which is really, really kind of cool. So you have selection probabilities, and then you have to do some adjustments. So one of them is a non-response adjustment. So as hard as we try, we go out, we ask people, please do the HINTS survey. Before, early on we'd call them up. Later on, we now send it through the mail. Lo and behold, some people don't respond, don't know why. $2, you think that would be good enough for them. But some people just don't respond. Unfortunately, that just happens in surveys. It's nothing unique to HINTS. So there's non-response. And so we have to adjust for that, for the number of people who didn't respond. And how would we know what percent should have responded? Because we can look at census and know, there's so many percentage of males and females, different levels of education. So when we don't hit that, we have to kind of adjust for that. And then finally, they do this thing called raking to control totals. Basically, what they want to do is they want to make sure for certain variables that if you weight them, you'll match almost exactly the population level values that typically we'll get from census. So for example, we do rake on age, gender, education, marital status, etc., using information from the American Community Survey, which is part of census. So again, let's say the survey was done in 2014. We can go to ACS in 2014 and know what percentage of people were of different ages, of genders, education, etc. So if you weight the HINTS data, you get almost exact numbers along those variables. And then we also thought, okay, we actually need to do a little more than that because we want to make sure we want to control for, or we want to meet those control totals for two other things, health insurance status and cancer status. So again, if you weighted the HINTS data using the final sample weights, you'll see a very, very close approximation of what that was for the population at that time. And most importantly, you use the final sample weight to get your population level point estimates. So those are your means, your proportions, et cetera. What are the average number of minutes that people do physical activity? What are the proportion of people who feel that they're high risk for getting cancer? So those are when I talk about when I'm talking about population point estimates. So that's why you use that final sample weight. Okay, great. So we can figure out how to get that point estimate. Now, very importantly, we have to figure out how we get our variance estimate. So you want to do some statistical testing. You want to compare groups. You need a p-value. You need a confidence interval. You need that correct variance estimate. Because HINTS does not use a simple random sample, it would be nice if we could. It would be nice if we could get everybody in the United States, 18 and older, non-institutionalized, get their names, and just randomly pick from them. Of course, that's really not feasible. We have to use this complex sampling design. Because of that, our variance estimates aren't going to be accurate unless we use a particular variance estimation technique. Now, for health surveys, HINTS, BRFIS, NHIS, hopefully people are familiar with at least some of these acronyms, there's typically two ways that you're going to get your variance estimations, your variance estimates. Either something called Taylor linearization or replication methods. So Taylor series is oftentimes a default method for things like SUDAAN, SAS. If you don't tell it otherwise, it will assume that you use Taylor linearization. And to do that, you need two pieces of information. You need to know what your stratification variable is, how the data were stratified for sampling. And you also need the PSU. You need the primary sampling unit. Now, I'm not going to talk too much about that because HINTS doesn't use that. But be aware that that is, well, one thing you need to know. You need the information to do that. And so BRFIS gives you that information, tells you what the stratification variable is, tells you what the PSU variable is, and then you just plug that into your code. More importantly, HINTS uses what they call replication methods. Okay? And really, this idea is we're going to delete mutually exclusive exhaustive parts of the sample and reweight these. Basically, the idea is, think about this. Okay, we get a sample from HINTS, 6,000 approximately. Okay, we could get a variance estimate for that group, but wouldn't it be cool if we could actually sample many, many times and then get variance estimates and then maybe figure out a way to take the average of those or something? Well, we can't do that because that's not feasible. It's expensive enough just to do one sample. But maybe what we can do is we can kind of resample within the larger sample by doing exactly what I was talking about. And so what they can do is they can create these replicate weights. Now, HINTS uses what they call Jackknife replicate weights. And those are available. And they're found on the data set. And they can be used in many statistical programs. Now, I'm going to make a point later on about SPSS, but I'll hold the punchline for that, because that's not listed there, and I'll explain in just a second. Okay, so what are the replicate weights? So if you look on the data set, you'll see each iteration has 50 replicate weights, typically at the end of the data set. And as you can see up here, what we're saying is how they were derived, that they were obtained by deleting 1/50th of the subjects in the full sample, and then basically reweighting. So in other words, we're kind of taking random samples within that and doing that 50 times, and then reweighting. And I'll show you a specific example of what I mean by that. So I just kind of give a little more detail. Since 4 had 3,500 respondents, so you eliminate about 70 people from each replicate. And actually, you're not deleting them, I should say. You're actually giving them a weight of 0. So basically, you're just kind of leaving them out of that replicate. And then you reweight to get up to your population values. HINTS uses what they call the JK1 method. I just want to point out there's many ways of doing that. If I had a sampling statistician up here, this person can explain exactly what why they chose the JK1. It has to do with the sampling technique. I do say if you want more information, the SUDAAN manual goes into a lot of detail about replicate weights and Jackknife replicate weights. And then here's a really wonderful resource. I'd highly recommend a book that you could read about it. Okay, and here's hopefully really kind of brings this to life what I'm talking about here. So literally, I took data from HINTS-4, cycle 4, and Ali showed you how to download those data. And here literally are 4 rows of data. So each row represents a respondent, a person. So I picked out here, 4 people. It happens to be subjects 19 through 22. This first column represents the final sample weight. So I was just talking about. That gives you your population point estimates. Now for HINTS-4 cycle 1, it's called person underscore FIN WT0. Now of course I would not expect you to know that, How did I know that? Well, actually, go back to if you go to the analytics recommendation document, it'll tell you exactly what that is, because you're going to need that. And I'll show you the code in just a second. So you can see here the final sample weight. So person number and subject number 19 represents 2,916 people in the population, etc. These columns represent the first 3 replicate weights in the data set. So imagine there are 50 of them. This is just 1 through 3. Keep in mind what I said is we're going to systematically delete 1/50th of the sample from each replicate weight and then re-weight them. So if we have a bunch of people who get zeros for this replicate weight, they're kind of being deleted, and I am doing air quotes for those on the webinar. This is an air quote. They're not being deleted. They're just getting a value of 0 for that particular replicate weight, and then we re-weight them. The same thing for this replicate weight, and same thing for this one. So it's not a surprise, given that we have kind of fewer subjects, 1/50th fewer, which is about, I think, 70 we decided. Remember I was saying earlier that the sum of each column needs to add up to that population level estimate, right? So as you can see for HINTS for cycle 4, what we knew from census was in 2014, there were about 237,659,000, et cetera, adult, non-institutionalized people in the United States. So we have to reweight these, and these columns need to add up the same. So, not surprisingly, each weight for a person who's included will actually go up a little bit, because remember, we're deleting about 70 people, have zeros there, so we have to reweight those and make them typically, not always the case, they will get a higher value there. So again, just imagine there's 50 of these replicate weights. Okay. Now, we'll talk about that Jackknife estimate of variance. I swear this is my only formula. I swear to God. So bear with me a little bit, because I think it's kind of, I'm hoping it's useful to understand how do you use these Jackknife replicate weights, and how do they create your correct estimate of variance? Okay. Imagine that we have, we're looking at some point estimate, average number of fruits and vegetables eaten. So it's a continuous variable. We can get a mean of that. We can get an average. We can use the final sample weight to get that population mean average. You get the idea there. Now let's say we want a measure of variance, variability, spread, around that mean. Okay? We could use the full sample weight, I should say final sample weight, to get that measure of variance around that mean, right? We could also do the same thing for the 50 replicate weights. We'd have kind of 50 other estimates of variance. So that's what this value is, sub I, variance sub I. To get your Jackknife estimate of variance, basically what you're doing is you are taking the deviation, the difference between what the variance you would get with any replicate weight minus what you got the full sample weight. So it's just a difference, just a simple difference, and you're squaring those and adding those. Okay? So again, you do basically like 50 times, right? You know, this replicate 1 minus full sample weight variance. Replicate 2 variance minus full sample weight variance. So you add all those up. And then there's, very importantly, there's this correction factor to correct for bias. Now this formula here, k minus 1 over k, is particular to the JK1 method. K in this case is the number of replicate weights. Keep in mind HINTS has 50. So of course 50 minus 1 is 49. Divided by 50 will give us 0.49. 50 divided by, 49 divided by 50. Let me take a step back. K is 50, minus 1 is 49, divided by K, 49 by 50 is 0.98. Whew. 49 divided by 50 is 0.98. Good. So you'll see that correction factor show up in some of the code later. Probably come back to this and just to kind of give you an idea. Okay, cool. Now you say, okay, cool, I'm ready to go. I understand what weights are. I'm going to apply my weights. I'm ready to apply my replicate weights. I'm ready to go and do all really cool things and do all these awesome analyses. Okay, which statistical software should I be using? So how do you decide? Well, I put up here typically used, so that's very important. Typically used, not always the case. SPSS, SAS, SUDAAN, Stata, M+. I assume people are probably familiar with a lot of those, not necessarily all of them. It's all very useful. I probably should have put up R, because I know people have used R before. So point taken there. With any of these packages, you'll get the same point estimates again, talked about means, proportions, etc. with any of them. Okay? So again, means, proportions, even your betas in your modeling. So unweighted or weighted, again, if you applied the final sample weights, you'll get the same point estimates, regardless of which statistical package you're using there. However, you're saying, wait, cool, great, I can do that. But I know I got to make sure I get my correct variance estimates. And how do I do that? Well, you need a program, as I was hopefully pointing out, that incorporates those 50 replicate weights or what you're using to get your correct variance estimates. Now, eventually, you're taking those variance estimates, turning into a standard error. And of course, that's what you're including in your modeling. And that's really the crux of it. You have to get that correct standard error. And I'm going to reiterate, because HINTS does not use a simple random sample, again, we have to use these replicate weights and use statistical software that can handle the replicate weights to get the correct variance estimates. So I make a point here. It's needed for doing statistical testing. Anything involves a p-value, confidence interval, anything like that. If you were to compare an analysis done with software that did not incorporate the replicate weights versus one that did, the standard errors will tend to be larger in the non-survey procedures. So in other words, if you were to compare, again, your standard errors will tend to be larger. So you may think, okay, keep it in mind when I do my standard errors, and then if your standard error is large, the overall ratio is going to be smaller, things like that. So it might be harder to reject the null hypothesis if you're using replicate weights, if you're incorporating the replicate weights. However, I would argue, well, okay, that's not so bad, because you're actually less likely to make a type 1 error. If you remember, a type 1 error from stats class is when you reject a true null hypothesis. In other words, you think something's going on here, there is a difference, but it actually isn't true. So it's going to be harder to do that if you do use the replicate weights, and those are the correct variance estimates, but it's just, again, if you were to compare a survey procedure versus a non-survey procedure. But it's actually a good thing because you are getting your correct variance estimates. Okay, I'm going to drive the point home a little bit more here about kind of hopefully showing you kind of what you can do with these different packages. And up over here, this first column, as are my SAS. This is SAS, but very importantly, the SAS survey Proc procedures. So there's Proc Surveyfreq and Proc Surveyreg and Proc Logistic in SAS. Now compare those versus just the non-survey procedures, you know, Proc Logistic, Proc Regression, those kinds of things. So I'm really talking about the survey procedures. Stata has those, SUDAAN has those, and SPSS has some of those, and then of course M+. These columns represent the different features of the software. The first row talks about Taylor linearization. Notice that all packages can use Taylor linearization to get your correct variance estimates. Very importantly, notice for the replicate weights, there's kind of a gaping hole here for SPSS. SPSS does not have a way to incorporate the replicate weights to get variance estimates. Don't ask me why. They haven't allowed that feature. So, very importantly, if you're going to use SPSS, be forewarned that there's limitations. Really, you can't use it to do any kind of statistical testing, anything that involves inferential statistics, because you're not going to get your correct variance estimates. You can get the correct population level point estimates, because there is that final sample weight. But again, that's your point estimate versus the replicate weights used for your variance estimate. So just be forewarned. You can do a lot of cool things in SPSS, and I still use it because I find SPSS very easy to use, especially for data management, or if I just want to run a quick analysis on the sample, but there's a limitation. They all can do the things that I imagine most of you would be doing, regressions, those kinds of things, those kind of models, linear regression, logistic regression, survival analysis, all of them can do that. But also, actually, I guess the one thing I want to point out with M+, it does have a unique feature is that you can use latent variables. I heard Dr. Hesse talk a little about maybe you want to do some structural equation modeling or path analysis. I should say structural equation modeling that involves latent variables. Well, M+ is really the only statistical package that can do those kinds of things. So it's kind of unique. It's actually a very powerful program. Okay. Let's now talk about statistical code. So again, you figured everything out. You know about how to do your replicate weights. You figured out, okay, cool, I know which statistical package I need to use. So now I'm really ready to go here. Okay, I want to show two examples, one using SAS code and another one using SUDAAN code. I know someone's going to show Stata in just a little bit, so that's great. This is a bivariate analysis. This is a crosstab, so cross-tabulation between two categorical variables. Education and gender is a relationship. I know not necessarily something that's going to rock the world, but at least hopefully just shows an example. So I'm going to show an example of using SAS Proc Surveyfreq. So again, Surveyfreq is a survey procedure done specifically for survey data that uses some kind of complex sampling design. So you kind of see. So you get the idea. You got Proc Surveyfreq, et cetera, et cetera. We are going to incorporate the Jackknife replicate weights. So here's var method is just a command. And again, this is some of the things. And so let me just actually go to the next one because I want to point out a couple of things, how you're going to incorporate those weights we talked about. Notice you have a command here called weight. That's a SAS command. And then you put the name of the variable name for that final sample weight. Again, that's going to get your population points estimates, means, proportions, et cetera. It's called person underscore fin weight 0. I mentioned that earlier. But we want to get our replicate weights, and how are we going to? We want to get our variance estimates. How do we do that? We need our replicate weights. We have a command called rep weights, and then we put in our 50 replicate weights. So it goes from person fin weight 1 hyphen person fin weight 50. Now the good news is, because these variables, these 50 replicate weights, are contiguous, we don't have to type out 50 variable names. Thank God. So we just put a hyphen and put the first name and the second and the last one, and it knows, okay, cool, there's 50 within that. I talked a little bit earlier about that adjustment factor, which I kind of messed up. The k minus 1 over k, 49 divided by 50 is 0.98, I swear. So that's kind of how you incorporate some of that information. It's pretty easy. And by the way, I pulled this code from the analytics recommendation document that Dr. Greenberg talked about. So again, you can imagine you can swap in variable names, et cetera. Here are the variable names. I'm looking at the relationship between education and gender. You can easily swap those out. Put in a chi-square test and those kinds of things. So you can obviously add whatever makes sense to you. I make the point down here, this procedure, Proc Surveyfreq, is equivalent to Proc Crosstab in SUDAAN. So again, it's kind of basically two ways of doing the same thing. Okay, let's talk about kind of more of a multivariable analysis, in this case, logistic regression. Now I'm switching to SUDAAN code. You'll see some similarities, which is great. So, and I think as Dr. Greenberg was talking about, I'm actually demonstrating what they call SAS-callable SUDAAN. In other words, it's not a separate standalone SUDAAN program. It actually operates within SAS. So literally within your data editor window, you can write SAS code and do some, do that data manipulation, and then write your SUDAAN code once you're ready to go to run a model. So in SAS-callable SUDAAN, logistic regression is called Rlogist. So you've got Proc Rlogist. That's just the name of it. So this should look very familiar. Data equals. We are going to use Jackknife weights. Remember that. We definitely want to make sure we incorporate those. Let me just kind of cut to the chase here. So again, that just looks familiar. We've got the weight command. So that tells you, okay, I want to put my final sample weight there. Awesome. We have our Jack weights command. Again, we're now going to put our 50 replicate weights. They're contiguous, so a piece of cake. And then we have to do this adjustment. Now it just has to use the command add Jack. That's just a SUDAAN thing. So you can see, again, pretty easy, pretty straightforward. And down here, of course, we have our model. We're going to regress these two variables onto our outcome. Have you ever soft cancer information using gender and education as predictors? I do make the point here that this procedure is equivalent to Proc Survey Logistic in SAS. So again, two ways of doing the same thing. Okay. Okay, cool. Merging data across considerations. So the T in HINTS is for trending. It was done on purpose. We want people, and because of course there's been successive iterations of HINTS, what a great opportunity to do some trending, or merging, I should say, merging data across iterations. And then you can decide what you want to do with those merged data. Okay, cool. So what typically do people do? So the typical use cases we have when you're merging across HINTS iterations is one of two things. Either you want to test for trends over time. Has the percentage of people who feel like they're at high risk for cancer, is that gone up or down over time? Now that we have many iterations of HINTS, not only can we look for like linear trends, let's go up, let's go down, we can look for more kind of complex trends. Is there some other type of trend, a cubic trend, a quadratic trend? You can test for those because you have several data points for that. So again, you might be looking for main effects. Again, as a portion of people who feel that they're risk for cancer, who worry about cancer, has that changed over time? What kind of trend is there? Or you may actually want to do an interaction. So in other words, has it differentially changed for levels of education or for gender? So not just, but have women or men shown differences over time in kind of a trend? Or you may say, okay, you know what? Actually, I don't want to look for trend. I want a larger sample size because maybe my population of interest could be cancer survivors, for example. Any one survey, or maybe it's a particular smaller ethnic group or something like that. Any one iteration maybe doesn't have enough people in there for me to do what I want to do. So I'm actually going to merge across iterations, but I'm not testing across them. I'm kind of merging them together to create a larger data set, a larger sample size. Very importantly, if you do that, you're making a bit of an assumption that whatever variables of interest have really not changed over time, because otherwise you're kind of introducing a problem there, because if it's changing over time, you're going to be kind of mixing together different estimates. And again, so you are kind of making a certain assumption that whatever outcome of interest hasn't changed over time. And of course, there's ways to test for that. This merging, again, I oftentimes think of it kind of stacking one data set on top of another one. It's really going to be based on some kind of common item. So you're going to match up some certain variables. I think Dr. Greenberg showed, if you ever look for cancer information, is a variable that's found in every iteration. Now, again, the name has changed a little bit, but so if we want to merge by common items, common variables, you're going to have to make sure you're going to line those variables up. You may have to change the name of one to make sure it's matching up if you've done merges in, let's say, SAS. But what's really great, of course, as Dr. Greenberg showed, go to the website, and not only can you find where there are common items, but it'll tell you, give you all that metadata, all that information about each variable. What was the name of it? What was the denominator? So you can make adjustments if you need to. But again, I think you can use that website as a guide, because we've gone to the trouble of saying, yeah, these are the same items. And so when you see those green boxes highlighted, you can have some comfort and say, okay, yeah, cool, this is the same variable over time. So I can do a trend on these variables. I know Dr. Hesse was talking a little bit about, okay, what happens if you're using HINTS-3? Because here's a unique issue here. Because it was done in two different modes, telephone, mail survey, self-administered mail survey, we have to test for mode differences. So whatever variable of interest, if you want to use HINTS-3, you're going to want to probably test for those mode differences. And I'm going to talk more detail about that, because you have to decide, well, am I going to use the weights associated with the telephone sample, the weights associated with the mail sample, M-A-I-L, or actually a combined one. And I'll talk when you would use each one of them. But very importantly, you need to create this merge file. Again, I think of it as stacking one data set on top of another. Not only do you have to match up the variables, whatever interest, whatever you're interested in, whatever predictor outcome, but of course, since you're going to probably want to do some statistical testing, you have to make sure your weights are lined up correctly. The final sample weight, one of those, and the replicate weights, we talked about those. Each iteration has 50 replicate weights. Okay. Let's talk a little bit more about mode effects. This is actually kind of an important issue, especially for you methodological geeks out there who think, wow, this is really kind of cool. Are there differences by mode? And this is really getting into the data. As I said earlier, it's really important to test for mode differences if you are using HINTS-3. Again, I'll talk a little more about, well, why do we care? What do we know about mode differences? And so we know from research done that there are differences in estimates when you do, oftentimes you do see differences in estimates dependent on mode. So keep in mind, for the telephone survey, you're talking to an interviewer, and they're asking you questions. And they're asking you, have you ever heard of this? What's your knowledge of that? These kinds of things. And you can imagine, versus on a mail, you get it through the mail, you're filling it out, no one's asking you questions, you're just filling it out. You can imagine for sensitive questions, that people over the phone may tend to answer in a more socially desirable way. And we see this. So for example, people tend to, on the phone, tend to say they weigh a little less than they really do. Or they're a little taller than they really are. Or they may say, oh yes, I've heard of that, I'm very aware of that. Because you can imagine, you're thinking about socially desirable things. Do you smoke? These kinds of things. So it can happen. I'm not saying it happens in HINTS, but something to be aware of. And the other thing I want to talk about, again, is this oral versus a visual stimulus. Again, think about telephone. Someone's describing, asking you questions. Do you do this? Do you do that? Versus a mail survey where you actually see all the questions. So you may see different amounts of detail. And so again, visually, you might be able to see other questions. And that may prompt you to change your response. And I'll give you an example of that in just a second. Don't know responses. So on the telephone, someone asks you a question. Do you think this? Do you think that? What do you believe about this? I don't know. You may say, I don't know. And so then, maybe they'll prompt you, please give an answer. I just don't know. Okay, cool. That goes down as a don't know. On the mail survey, usually we don't give don't know options. So through the telephone, you'll tend to see more don't know responses. Just something to be aware of. And in extreme answers, this is kind of interesting. On the telephone, you tend to give more extreme values, strongly disagree, strongly agree. And I think I'm not sure. I think it's probably maybe kind of a primacy or recency effect, like the first thing you hear when someone asks you, or the last thing. That's my thought. And again, as I was talking about in HINTS 3, there are weights, final sample weight, replicate weights, if you want to use the RDD sample, the address sample, or combined. And again, you're going to want to test for that to decide which one to use. I'm going to go into more detail, and I know Ali is going to show you specifically some code about that. So hopefully this kind of drives the point home a little bit. So on the left-hand side here, I talk about a self-administered survey and kind of the ability to look ahead. So you can see the first question asks, have you ever looked for information about health or medical topics from any source? Now, maybe your first answer is, nah, I don't think so. But then, again, you're looking at this, and you look down here, you say, the next question asks, the most recent time you looked for health or medical topics, where did you go? And you're reading that, and you're like, oh, books. Oh, actually, oh, you know what? I went to the website. I went to WebMD the other day, or something like that. Oh, yeah. No, actually, turns out I did check on that. So that gives you more information than you would get over the telephone, because again, telephone asks you the first question, cool. Move on to the second one. You get the idea. Extreme answers. I was talking about this a little bit. So here we have examples using the mail sample in the blue bars, the telephone sample in the red bars. The question is based on the most recent search about health and medical topics. You were concerned with the quality of information, and you either strongly agree, disagree, or strongly disagree. And if you notice here, people on the telephone tend to answer at the extremes. They're more likely to say strongly agree, and more likely to say strongly disagree than the male respondents. Interesting. But again, it's not. Here's one example, but it's not always going to be the case. So you need to kind of test that out to see if there are differences. Okay. So here's an example of how you decide what to do. You do want to trend across the iterations. So how do you decide which weights to use? So here in this table here, these numbers 1, 2, 3, 4 represent HINTS iterations. So HINTS 1, HINTS 2, HINTS 3, and 4 plus. So moving forward, this first row tells you whether or not what mode it was. Was it done in RDD? The second row tells you whether or not this is a mail survey. And here's where we have a combined weights. So as you can see, HINTS 1, 2, and 3 were all done, all have RDD mode weights. I'm sorry, I'm confusing that. I'm kind of conflating that a little bit, but you kind of get the idea there. For HINTS 3, we have RDD weights, mail weights, and combined weights. And then for HINTS 4 plus, forward, we only have mail, because it's only done through the mail. Okay, so let's say you want to trend over time, and you have particular outcomes of interest, and you're doing all your testing. Again, Ali's going to show you how you would really how you would compare the two estimates. So again, I'm comparing the RDD estimate versus the mail estimate. Let's say, for example, there are no significant differences between modes in HINTS 3. You've tested them out, no differences by mode, cool. that makes your life pretty easy, because then what you can do, if you want a trend, you can easily just connect all the iterations. We're going to use the RDD weights for hints 1 and 2 because that's all we have. We're going to use the combined weights for hints 3 because there's no differences. So might as well take advantage of the combined sample. It's actually larger, so that's good. And of course, hints 4 plus only uses the male weights. So we have this nice way of connecting. The only difference here is we're going to use the combined weights for hints 3 and then the male weights going forward. So now we have this nice trend over time. Where it gets a little trickier is when you do have significant differences. We found significant differences, and there's nothing we can do about that. Now, what do I mean by significance? So there could be statistical significance. I'm comparing the male mode versus the RDD mode, and let's say I do a t-test, and yes, the means are statistically different. Or it's a categorical variable, and I want to do a chi-square test. And yeah, it turns out p-values tell me those are different. Now, the knee-jerk reaction is like, okay, they're different, nothing we can do about that. Well, I think this is where you need to be a little more thoughtful, because small differences can be significant. And so you have to really think a little bit and think about, we talk about clinical differences or clinical significance. So between those, so again, as long as you have a good rationale, you can defend that of why you either found differences and decided, no, it's really not that different, because again, maybe 1 or 2 percentage point difference in a proportion can be significant. The sample sizes are fairly large. Chi-square tests are sensitive to large sample sizes. But again, if 1 or 2% difference, and maybe there's some reason, theoretical reason why you can say, yeah, these are different statistically, but really, for all intents and purposes, they're not. Then maybe you can have a good justification why you would use the combined. But let's say again, statistically different. The two estimates are way different. There's no way we could trend across the mode because the mode is making a big difference here. So again, that's what I'm talking about here. So what you need to do is really kind of do two different types, two analyses. So for the connecting hints 1, 2, and 3, again, the common mode there would be the RDD weights. That's kind of nice. Moving forward, looking at trends, then you're going to want to use the male weights, again, knowing that hints 4 forward only has male weights. So in other words, you're kind of saying, okay, so the trend between hints 1 and hints 3 was this, and then hints 3 forward is this. And again, hopefully maybe they're both linear or something like that, or they're both quadratic. And you're like, okay, cool, I see some similarity here. But again, you're kind of, this is what you're stuck with, given that, again, if you find significant mode differences. Okay. Here's a very busy slide, but bear with me for a little bit. So what I want to do is I want to talk about how do you combine, what are you doing when you're combining across iterations? And again, Allie's going to show you specifically code that does that. So let's say, for example, we want to merge 1, 2, 3, 4 iterations of hints, those first 4 rows, hints 2, hints 3, hints 4, cycle 1, hints 4, cycle 3. And then we're going to create this combined data set. Literally going to stack 1, 2, 3, 4 data sets on top of each other. Now the nice thing is, each iteration will have a final sample weight, of course. So literally, we just kind of align those variables. Each data set has one final sample weight. Just got to make sure they have the same name, so then we can just kind of line them up. So again, in this combined data set, here's a final sample weight. We call it, this is just for illustrative purposes, total, TWGT0. It's got to have a different name because you want to line those up. Well, very importantly, for hints 3, I'm assuming that we test for mode differences, didn't find any, so we're going to use the combined weights. Okay, remember that each iteration of hints has 50 replicate weights. So if we merge them, we're actually going to have 50 times 4 replicate weights. We're actually going to create 200 replicate weights. Don't be too intimidated. It sounds like a lot, but again, we have some code that helps you kind of do all this. I want to point out a couple things. Here's your final sample weight. So again, replicate weights 1 through 50. So each person will have 200 replicate weights. For anybody in hints 2, those 50 replicate weights are literally the replicate weights that came from the original survey, right? Just pulled those over. For the rest of the weights, it's actually copying over the final sample weight. So it's basically a constant for everything else. And notice you're going to see a trend here. For hints 3, weights 1 through 50 are the copying over the final sample weight. 51 through 100 are the replicate weights that belong to that particular iteration. And again, copying over, same thing for hints for cycle 1, where replicate weights 101 through 150 are the actual replicate weights, and everything else is a constant. And hints for cycle 3, you get the idea here. Final sample weight copied over, and then finally replicate weights for 151 through 200. Now, the reason I point this out, hopefully this is useful, if you go back to that formula I had, remember we said, okay, we're going to take the difference between each replicate weight, difference between the difference between the variance estimate from using the replicate weight minus the variance estimate from the full sample weight, take the difference, etc. What I'm trying to point out here is that, keep in mind, if these are constants here, we take variance estimate from using the replicate weight minus the variance estimate for the sample weight, that's going to be the same number, right? So all of these replicate weights will go to 0, the same number being subtracted from itself. And so the replicate weights that apply to people in hint 2 are only the replicate weights that were used in that iteration. Same thing for hints 3, hints 4, cycle 1, hints 4, cycle 3. So the point is that because of the way the formula is done and the way that these are set up, only the replicate weights that apply to that individual will be used to create the variance estimates. Okay, hopefully that's helpful. Okay, so I want to point you to example code for combining data sets. We actually have some of those in our staff reports and set up the weights. Ali is going to show you illustrate later. I didn't mention these are in the staff reports. Note that the process that I just illustrated is going to be the same if you're going to be using the HINTS-FDA data. Now, those aren't available yet, I think in June, but just be aware. So if you want to merge HINTS-FDA data with regular HINTS data, I don't know what the word is there.
They are available internally for FDA staff, but for people watching externally, they won't be available.
Okay. Yes. So thank you, Kelly. Kelly just reminded me. Those are available for NCI folks and FDA folks. And those will be released to the public in June. So my point is here. So creating the merge file is really the hardest part because you got to make sure all the variables line up and you have your variable names are the same and make sure your weights are the same and your replicate weights, etc. Again, we have code for all this, so don't fear. But it really is the hardest part in my mind. Now, typically, you're going to add a variable designating survey year, and that's, again, Ali's going to show you how to do that, and that's pretty straightforward, assuming that you want to maybe compare, across iterations to see if there are differences. But once you have all this set up, you can kind of treat this as one large data file, and there's a grouping variable for survey year. You could use it like any other grouping variable, gender, education, race, ethnicity, to compare across or look for trends across. So that's kind of nice. So again, that to me is the hardest part. But once you have that, you're ready to rock and roll. So I think that's my last. So thank you very much. I think Ali, come back up. That's you. Okay.
Dr. Hesse, if you want to come up to the front, we're going to do a quick question and answer session. Yep, cool. So for those on webinar, as I said, thank you for holding your questions. So for those on webinar, there's a place where you can submit your question, and we'll take those up here. For those in the room who might have any questions, feel free to come up to the mic. We do want to make sure the webinar attendees can hear. And feel free, we threw a lot at you.
For all people. For the HINTS-FDA, given that it's not available to the public yet, would we not be able to see the code book and the surveys so we could get a sense of the content?
Yeah, I think we actually have.
Kelly, why don't
Kelly,
you
can you,
the mic?
sorry.
Yeah. This is the full management team here.
Yes.
Mic for you.
So the question was about whether in the next month before the HINTS-FDA data set is public, whether you could at least see the survey instruments in advance to get a sense of questions. And the answer is yes. I feel like we do, and I'm looking at Brian, but in the past we have posted the survey instruments just so people can get an idea in advance. So I think there wouldn't be any problem with doing that over the next couple of days even. So.
Clear as mud, huh? you have any questions coming in on the webinar? Nope. Right. Oh, there we go. Oh, yay.
Okay, so can you hear me?
Tip it up a little bit more. Yeah.
So you mentioned that SAS-callable SUDAAN was the software package of choice, but based on what you were talking about, Rick, it sounded like the main concern was making sure there was an opportunity to use the replicate weight.
Correct.
So could you talk about potential differences between using Stata, that's my software package that I know the best, versus using SAS, and most of the code that I've seen in the Analytic report seems to be more SAS-oriented. So I wondered if there would be a future opportunity to have access to more Stata code, and maybe with the FDA module that's going to be relevant today too.
So yeah, good question. So what I would say is there's really no differences if you were going to use the SAS, Proc survey procedures, SUDAAN, Stata, R. They typically use the same algorithm. So maybe you'd see a difference at the 5th decimal place or any estimate or something like that. But for all intents and purposes, it's really those are interchangeable. So again, as long as it can incorporate the replicate weights. You had a question. Oh, Stata. So yeah, we realize there's a lot of Stata users out there. We have just kept it to the SAS code, SUDAAN code, and Stata code, thinking those are the ones that most people use. We do, for every iteration, I think for every iteration, we do have Stata data, that's good. And so data in Stata form, and I'm pretty sure we have code for that for just about everything. I know certainly from, at some point we said, okay, we know we need to provide Stata code. So that, hopefully you'll be able to find that in the analytics recommendation document. So look in there for any iteration for example Stata code. Did that answer your question? Okay.
And that's a good reason to tee up Betsy's presentation on HINTS-FDA, because she used Stata for her analysis, and she's going to walk through what she did for that in just a moment.
So we have a question that came from Aaron O'Brien via webinar, and I believe this is probably for you, Dr. Moser. Hi, is there a minimum cell size that will be required to provide accurate estimates per the Jackknife weighting method? Would we need at least 2, 30, or 50 people per cell to get reasonable estimates of the population?
So that's a good question that comes up a lot, and this is an important issue because especially for any one iteration, your cell sizes may be small depending on obviously whatever variable of interest. And really we're talking about the sample cell size, not the weighted cell size, because of course that's just used to get your weighted estimate. So again, we're talking about the sample cell size. So we typically use a rule of thumb. I've heard different things. I would probably say you probably want at least 50 people in a cell in order to get some kind of accurate estimate. I've heard 30. I don't know if there's any one thing that everybody would agree on. I'd probably say 30 would be the lowest, the smallest cell size you'd want to use. If you want to say this is a accurate estimate of whatever variable of interest. But 50 is probably a little safer.
Thanks, Rick. And I know FDA has a rule on that, right, internally, and what's the cell size? A minimum of 50. So for the people at FDA that are working on the data set internally, that's kind of the rule that they're using. Certainly when the data go public, people can establish their own rules for that, but that's certainly the recommendation that FDA has. So.
All right, do we have any more questions in the room or on webinar? All right, then with that, I will hand it over to Elizabeth Betsy Donaldson, who's a social scientist in the Office of Science at the FDA. And as has been mentioned several times, she's going to be our Stata go-to person. So if you're a Stata fan, here you go.